This is Module 12, Lesson 7, Summarizing Categorical Data. After this lesson, you need to be able to organize categorical data in a two-way frequency table and determine the values in a two-way relative frequency table. Let's learn about two-way frequency tables. A two-way frequency table, or sometimes called a contingency table, is used to show the frequencies of data from a survey or experiment classified by two categories. And honestly, sometimes you might have three categories, but we'll get there later. In them, the rows indicate one category and the columns indicate the other. So here, suppose you're constructing a two-way frequency table based on two categories, grade level and employment. The table is constructed below for sample values. So grade, we have juniors and seniors, and then they either have a job or they don't. So they're either employed or unemployed. Most of the time, at the bottom and on the right side, you will have columns for totals. Sometimes they don't show them, and if they don't show them, you're going to need to add them because they are an important part here. One side note real quick, it doesn't have to be just two choices. For example, if we had more room, we could add in another category for like sophomores. Okay, if we had more room, we could add in another category for freshmen. So it doesn't just have to be 2 by 2. It could be 4 choices from one thing and 5 choices for another thing. A two-way frequency table just means there are two categories, not necessarily how many choices there are in that category. Other important things you need to know about are called subcategories, joint frequencies, and marginal frequencies. So subcategories are the column and row headers that represent the types of categories. So in this case, we had employed or unemployed, and then junior and senior. Next, there's joint frequencies. They're the values for the combinations of subcategories. So if we were to look at our table, 8 is our joint frequency. They're where they join. There are 8 juniors that are employed. Marginal frequencies are the totals for each subcategory. So the marginal frequencies are your totals. That's a marginal. Margin means the edge. So your marginal frequencies are on your edge, your totals. Example 1. Use a two-way frequency table. Our real-world context is names. Unisex names are often used for both males and females. At one point, the most common unisex names in the US were Casey and Riley, with 176,544 Caseys and 154,861 Rileys. During that time, there were 104,161 males with the name Casey and 75,882 females with the name Riley. Organize the data in a two-way frequency table. Steps 1 and 2. Enter the given data in a table, then use the information given to fill in the rest of the cells. For a two-way table, to fill in information, numbers add together to get the total. What I mean by that is this number plus this number is going to equal this number. This number that we don't know plus this number is going to equal the number over here. And even in our totals, 176,544 plus 154,861 is going to equal whatever is there. So adding across will equal our total. It also works by adding downward. So 104, 161 plus whatever that number is going to equal 176,544. And then the male Rileys plus this number is going to equal that total. And then whatever that total plus that total equals that total. So they add sideways and down, which is a way you can check. At the very end, your last one should come out to work, and if it doesn't, something's wrong. So let's start filling things in. For the male Rileys, so I'm trying to find out male Rileys. I know that this number here that I'm missing plus 75 has to equal 154. So if I go backwards and subtract, I can end up with male Rileys is 78,979. Now that I know that number, I can figure out the total number of males by adding across. 104,161 plus 78,979 equals 183,140. Now we have that box and we can use it when we need it. Next, we can figure out the number of female Caseys, which is over here. Again, we know the males and we know the totals, so if we subtract, we get 72,383. Now we know that. We can add going across to get 148,265. And then finally, for our totals, to get our what I call the total, we can either add across to get this number, or we can add going down to get the number. I suggest doing it both ways. If you get the same number both times, you did it correctly. So 331,405. If I add from left to right, I get that number. And if I add top to bottom, I also get that number. At the end, once I get the same number twice in a row, your whole table will most likely be correct. So recap, rows add to the totals, columns add down to the totals, and then your totals will add to the total in the bottom right corner. And just as a reference, if we happen to have like another column with a number here, and a number here, and a number here, maybe there's a third name they gave, all three of these would have to add to the total. Check to see if you understand. Read through the situation and fill in the two-way table. Here, they didn't give you any to start with, but all the information you need is in the text. Pause the video and organize the data in the two-way frequency table. Check your answer. First, it tells you of the people interviewed, which tells you that's a total. 423 earned less than 50,000. 328 earned 50,000 or more. Those are your totals of people that earned more or less than something. Then, of those earning less than 50,000, 262 thought people's lives would be better. So 262 were better, less than 50,000. 240 who earned 50 or more thought the same. So 240 thought better and 50. But we can fill in the rest. So the next one I could fill in 161. It doesn't matter what order you fill them in. I subtracted to get 161. Then next, I can figure out that's 88. Adding down, I could get 502. Adding the worst together, 249. Adding the totals, 751. It doesn't matter what order you're doing them in. Eventually, you will fill in all of the cells. Let's learn using statistics and representations. A relative frequency is the ratio of the number of observations in a category to the total number of observations. A two-way relative frequency table can help you see patterns of association in the data. To create a two-way relative frequency table, you just divide each of the values by the total number of observations and replace them with their corresponding decimal or percent. Similarly, a conditional relative frequency is the ratio of the joint frequency to the marginal frequency. And because each two-way frequency table has two categories, each relative frequency table can provide two different conditional relative frequencies, depending on if you use the marginal frequency on the right side or the marginal frequency at the bottom. Example 2. Use a two-way relative frequency table. Our real-world context is parenting. Many parents monitor their teenagers' internet usage. The Pew Research Center conducted a survey of whether parents do or do not check what sites their teens had visited and whether they are the parent of a teen between the ages of 13 and 14 or between the ages of 15 and 17. The results of the survey are shown. Organize the data in a relative frequency table by age group and interpret the data. So here they gave us the frequencies already. It may look like this is already complete for us. However, we now want a relative frequency table, which means instead of each cell containing the total for that category, we need to figure out the percentage. So for a relative frequency table, we're just going to take the total that was in each box. So for example, this one had 299. If we go back, 299, and we divide it by the total, which is 1060, where do we get that number from? That was our total. So each relative frequency is just going to be the percentage when you divide the cell divided by the total. So if we look, 299 divided by 1060 would give us a decimal of 0.282. And then if we wanted to change that to a percentage, we would just multiply by 100. We can do this for all of them. With relative frequencies, and this only works for relative frequencies, not for conditional, percentages act like you're used to, where the totals add up to the total. Same with the numbers going down. The percent plus the percent equals the percent. So part B, interpreting the data. Do more parents check what sites their teens have visited, or do more parents not check? So we don't care what the ages are. We just want to know if they're checking or not checking. So let's look at the total. 61% do check, where 39% do not check. So 61 do check, 39 did not. And that's basically all there is to a relative frequency table. Find the percentage so you can compare. Example 3. Use a two-way conditional relative frequency table. Our real-world context here is voting. According to the U.S. Census Bureau, voter turnout describes how many eligible voters show up to vote in an election. The table shows the number of eligible voters who did and did not vote in 2012 for the oldest and youngest eligible age groups. Organize the data in a conditional relative frequency table by age group and interpret the data. So again, as we learned in the Learn section, conditional relative frequencies have two possibilities because it's based on the joint frequency and then one of the totals. So we could take our joint with our total for the age group or the joint with the total for here it's voted. So we just need to figure out which we want. So first step, we need to determine which marginal frequency to use. Conditional relative frequency relates the number of voters or non-voters to the age group. So our relevant marginal frequency are the numbers for the age group, which means we're going to be using our numbers over here based on our age group. Now that we've figured out which marginal frequency to use, we're going to determine the ratio of the joint frequencies to the marginal frequency. So I'm taking the frequency that was in this box here and dividing it by the total for that age group. So our joint frequency here was 12,515. Our total was 25,790. When I divide, then I get 48% of this group voted. So let's figure out what percent did not vote. I'm going to take the joint frequency of that did not vote, 13,725, divide that by 25,790, and here I get 51.5%. You can check to make sure you're doing stuff correctly because your total should add up to 100% for whichever marginal frequency you used. Just be careful if you're thinking about the last example and how everything added up to 100%. This does not work the same way. It will be 100% going either across or going down, but usually not both. Let's finish and figure out our percentages for the 75 and over. So the total here was 16,724. Dividing that out, 67.8% voted. And then they gave us that 32.2% did not vote. Based on this, now we can interpret the data. Which age group had the higher voter turnout? Well, the percent of eligible voters between ages of 18 and 24 was 48.5%, and those 75 and older was 67.8%. If we're looking at who voted, then people 75 and over were more likely to vote. Or the way they worded it here, people aged 18 to 24 were more likely to have not voted than ages 75 and over. So as you're doing this, just be careful. Make sure you're choosing the correct marginal frequency, then its division to figure out the percent, just as it was before.